Hello and welcome to this first tutorial on the Tidyverse, importing and cleaning data. My name is Wouter van Attenveld from the Vrije Universiteit Amsterdam, and you can go to vanattenveld.com/r for a link to all the tutorials that we have on R. So let's talk about the Tidyverse. If you want to use the Tidyverse, of course you need to have Tidyverse installed. If you don't have it yet, you can install it by saying install packages Tidyverse, or by going to the packages tab and click install and select Tidyverse here, and then press the install button. If you haven't done so, please do so now, as that will probably take quite a bit of time to install everything, because the Tidyverse is not just a package, it is actually a pretty large collection of packages. And if we activate the Tidyverse by saying library Tidyverse, you'll see that it actually loads something called ggplot for visualization, Tibble, which is the basic data structure, reader for reading in data, dplyr for manipulating data, and actually in this and the coming tutorials we'll be seeing a lot of these different packages used. For now, what we're going to do is basically in this session two things. One is I'll explain to you the concept of tibbles, which are basically Tidyverse's alternative to the data frame, and we're going to see a small set of functions, namely the filter, select, arrange, and mutate, which we will use to manipulate tibbles in various ways. But first, let's have a look at tibbles. If we want to create a data frame, a tibble, we can do so manually. For example, we could have 3 respondents which have a gender column maybe, and maybe they have a height. So that's a bit long. And we can do it like this. If you run this, you will see that it actually creates a little data frame with 3 columns. The first column is an integer, which means it's a numeric column, 1, 2, and 3. The second is a character, and the third is a double, which is also numeric, but it could include decimal signs. We've run this command, and then it displays it on the screen. It doesn't actually save this data frame. If we want to save it, we need to assign it to a value. And so now we say d equals the result of running this tibble command, and it has created a new variable, new object here called d, which we could click, and then we see it in a slightly nicer fashion. It's the same table, of course. Now, it'd be a little bit boring if we would always read our own, if we'd always have to type our own data. So what we're going to do is actually use the read CSV commands to read a CSV file. A CSV file is a simple file that can be read in Excel or SPSS, but also in R, that stores data in a tabular format. And in fact, what we will be doing is we will use a data set that is published by 538. And so if we would go to 538, they have a GitHub page, and their GitHub contains a lot of nice data. And now we are going to look at the guns data. So let's have a look here. So they have a poll quiz guns, which has a CSV file here, and then we click on the raw to get the direct link to the raw data. So this is simply the CSV file, which is on the internet, on GitHub. We didn't download it, we didn't do anything. We just take the URL here and immediately put it into our command here, and voila, now we have a data set consisting of 57 different polls. And so for example, the first one is a poll from CNN taken in 2018 on whether the legal age for having a firearm should be raised to 21. Under a population of registered voters, 72% were in favor. Democrats were more in favor than Republicans, and if you want to see more details, you can visit the actual poll using the URL in the last column. So this is a fairly simple data set, which we will use in this example to show some of the things we can do with Tidyverse. The first thing we very often want to do with data is to use filter. The filter command can have us select rows. So filter is for subsetting rows. For example, you could say from D we want to take all the rows where, for example, the question equals age 21. And then you see it only gives us the 7 polls that actually deal with this question. We could also say I would like those with age 21 and where the population is all adults and not just registered voters, and then we only have 2 polls left. You could also say I would like age 21 or say support, well, let's say or question equals, I think armed teachers is one of them. And so that's whether teachers should also be armed in classrooms so they can deal with presumably gunmen that enter this classroom. And so you can use the ampersand to say and, the vertical bar to say or. You could actually also do the same with a comma instead of an ampersand, just has the same results. And finally, of course, you can also use other things than equals. For example, you could say I would like to have all the polls where the support is smaller than 50, so where an average people are against it. And then we'll see that there's one poll for repealing the Second Amendment that didn't make it, actually by a pretty wide margin. And there is 6 polls on arming teachers that also didn't make it, even though Republicans were actually in favor of arming the teachers. So this is basically the first command, which is called filter, which you use to select rows, generally based on some sort of criterion. And you can say only male, only female, only this group, only that group, only rows with a value above or below a certain value, etc. Finally, all the commands I ran printed it on the screen, but we didn't actually save it. So suppose we would like to save the results of filtering on H21 as a separate datasets, we would have to assign it to something. So here we say filter D on and select only those rows where the question is H21 and store them in a new object called H21, which is stored here, which has 7 observations. So we've seen how we can filter rows. Now let's look at how we can select certain columns. This is done with the select commands. So filter select rows, select columns. In the most simple case, we could say we only want to select from this datasets the support column, say the support column maybe and the pollster. So we say I want to select the pollster and I want to select the support column. And then we are left with a table containing only those 2 columns. What we could also do is say we want to have everything from question to support with a colon here. And then you get all the variables from question to support. We could also say I would like the question column and then everything from the pollster column to the support column. And then you get it so that you can combine enumerating columns and you can give a list of columns. And you can also rename columns. So for example, we could say I want to call the support column the sub column. And so now you select the question column and the support column you rename as sub. This renaming is especially important if we look at columns which, for example, have a space in them. So we have something called Republican support, I believe here. And we have something called Democrat support. Let's see if I can type them. No, I cannot type them. Probably Democratic support. Yes, there we go. And you see it actually lists those columns, but it has little backticks here, and it means we always have to use quotes or backticks when we are using them. So that's all very complicated. So what in fact we will do is say that we call this rep and we call this dem. And so then we could say we would like the pollster, we would like the support column, the Republican support and the Democratic support. And now we have a data set with nice column names that make it much easier to continue working in. So we just call that the H21 data set from now on, and which is earlier we filtered it, and now we also filtered the rows earlier, and now we also select columns, and we also rename 2 columns to make it easier. What is important to remember is that if you use select to rename columns, it will actually drop all the columns you don't explicitly rename, right? So if we did this, it will only give us the subcolumn because that was the only column that we remembered. The alternative is to use the rename function, which does exactly the same thing, only apart from renaming one column, it also keeps all the other columns. And so select drops everything you don't select explicitly, renames keeps everything but allows you to rename 1 or more values. Finally, there's an option to do a negative selection. So we could say from H21, we would like to drop the support column. And then we only have the rep indent column left, right? So we've dropped the support column here. So to recap, in selecting, you can select columns. You can specify one column. You can specify multiple columns. Earlier we saw question colon support. You can rename columns, and that is especially important if you have columns that don't work as variable names in R, so mostly if they have spaces in them or if they don't start with a letter. And you can also drop columns. If you only want to rename columns and you don't want to drop the rest of the columns, you can use the rename function rather than the select function. Right, so now you've seen how you can filter rows using the filter command. You can select columns using the select command and rename them either in the select command or using the rename commands. The next command I want to talk to you about is the arrange command. The arrange command can be used for ordering data frames. So if we look at the H21 data frame, you can see it's actually unordered now, really. So we can use the arrange command to order it, for example, by support. And then you'll see it is ordered by in increasing value by support. You can also make it in decreasing value by using the function desc for descending. And now it's in descending support, descending order of support. One trick for numeric values is that you can also sort by minus support, and then you get the negative support in increasing order, so the normal support in decreasing orders. That's the same result basically. The biggest one goes first. You can also sort by text, for example the pollster, then they put it in alphabetical order. And finally, if there's ties, for example there's two polls with a Republican in the same value, you could say I'd like to support them first by Republican support and then by Democratic support. So then you see that within the tie for Republican, it's sorted in increasing value by the Democratic. If we move this into descending, and then these ones are flipped around again. So what you've seen here is with the arrange command, you can arrange by one column, you can arrange by multiple columns, and you can do it in increasing order or you can do it in decreasing order, either for numbers, in which case it's your normal numeric order, or for text columns, in which case it is sorted alphabetically. Now, the final command I'd like to talk to you about is the mutate command. Mutate, where before we haven't actually added or changed any data, we've just selected certain piece of data. With the mutate command, we can also change the data. So, for example, you could say mutate. We would like to create a new column, let's call it X, which is the result of adding 10 to the Republican support. And of course, we need to tell it what to mutate, sorry for that. So we'd say mutate the H21 data frame, create a new column called X, which should be the result of adding 10 to the column Republican. And then you say it's create a new column X, which is 10 bigger than the Republican column. As before, this is just placed on the screen. If we actually want to save it, we would have to assign it to a name. So now we override our existing name. We could also have created a second name, and now we have actually created an extra data frame here. So whenever you run a command that changes data, you can either override your old data or you can create a new data frame. Now this isn't really very useful, but what can be useful is, for example, to say that we want to mutate H21 to compute the difference, which could be, for example, the Republicans minus the Democrats. And there we see how much more popular a certain value is for the Republicans than it was for the Democrats. So here the Democrats are 25 points lower than the Republicans are 25 points lower than the Democrats. And you can see that for all of them it's a negative value. So in general, Republicans are less likely to agree to increasing the age of firearms in the United States than Democrats are. Let's actually save this, so we'll call it H21. And let's also remove the X column again by computing it to be null. That's another trick to remove it. Of course, we could also have used this notation with a negative selection to achieve the same thing. But now we have our H21 data set, which has the original columns and a newly calculated column. Now this column, now we added a column. You can also change existing columns. So for example, we could say mutate H21. For example, if we know that the Republicans are underestimated, so we should increase all the Republicans by 5 points. And then you'll see this one used to be 61, it's now 66. You can change a column that is already existing. And so if you want to change a column, just assign to an existing name. If you want to create a new column, you assign to a new name. Now these are all the functions we wanted to talk about today. So we have the tibble command, the read CSV command, the filter commands, the select command, the arrange commands, and the mutate commands. And of course, there's a handout in which you can practice with all these, and the R4DS, the R4 Data Science chapter, and the Computational Analysis of Communication chapters, all of which are linked from the vanettevel.com/R websites. Before we go, there's one there's one final thing I want to talk about, and that is the idea of pipelines. So what you've seen now, that to create our data sets, we've gone through a number of commands, right? We've loaded the data. We have filtered it to only include one of the questions. We have selected only some of the columns. We have then computed a new value, and then say we wanted to arrange by our newly calculated value. Right, so this is basically a set of commands that we gave, and if we clear the workspace, so we start with 0, and we run all the commands from top to bottom, you'll see that the end result is a data frame where we have the difference between Republicans and Democrats on the question of whether the legal firearm age should be raised, sorted by the difference between Republican and Democratic support for that motion in that specific poll. Now, what you see here is that basically every command started with the output of the previous command, stores it as something, and then the next command takes it up and stores it again. And so basically every command does something to the result of the previous commands. And because that is so often the case, instead of forcing us to assign it every time to a new temporary variable, there's another way of doing the same thing, and that is using pipelines. So basically, if we use a pipeline, and let's actually have a little variable for the URL because it's pretty long. What we basically do is after every command, we can add a pipeline operator, which is a percentage sign bigger than sign percentage sign, which you can quickly create with Windows Control Shift M. So if you press Control Shift and M, you get the pipeline operator. And what it basically means is then we can give the next command immediately after this, but we don't have to supply the data anymore because the output of this command is given as the input for this command. So basically say read my CSV from that URL and filter it to only give us those questions. And then we can add the next command as well, so we can do our selection here. And we can even immediately do the mutation as well. And why not also do the arrange? And so we've now given a series of commands, which we call a pipeline of commands, where we start with reading, filtering, selecting, mutating, and ordering. And the result of this is, of course, exactly the same data frame. It's stored in memory now. If we want to save it, we could call it H21 and run it like this. And now we have our H21 data frame. So this set of commands and this set of commands do exactly the same thing, and there's no reason why you should always use this one or why you should always use that one. I tend to group all the commands that logically are part of the same sort of group of things that I do together in one pipeline. That is totally your choice. You can use this one, you can use that one. I only wanted to show it to you because you'll see this used quite a lot if you search for help or something, and it means that you don't need to be scared about it. The only thing you need to remember is that if you use the pipeline, then in the next commands you do not specify the data set anymore, right? So this little D here got dropped because the output of this command is automatically used as the input of this command. For the persons among you who like the more formal approach, suppose you have a function f and you say y equals fx, and then you say call g on y. So then essentially what you're doing, of course, is running G on the result of running F on X, right? And this is exactly the same thing as saying Fx run it on G, right? So this is exactly the same as this, is exactly the same as this. Which of those three you prefer is totally a stylistic choice. I tend to mix them. I usually, if I load my data and I know I'm only going to use certain columns or rows, I will very often include the filtering and selecting with the reading, so that I never have the full data set stored in memory. But then probably if I then need to do some pre-processing, I'll do that in separate commands. So you can totally mix and match these. For example, you could say h21 equals this, and then stop, and then we start again by saying mutate h21, and then basically you get exactly the same result again. So you can mix and match these two different ways of running the commands. Again, don't be worried if you think this is all overly complicated. Feel free to only use this one, feel free to only use this one, feel free to play around with it as you want. The only reason I wanted to show it to you is because you'll probably see this being used, if only by me, and it's good to know which of the two you can use. On that theme, I suppose there's one other thing I should have talked about. I tend to use x equals 5 to assign 5 to the value x. A lot of our users use the arrow notation. So they do a little arrow and then they say 5 should be inserted into the object x with an arrow. These two are totally equivalent. The hardcore R people generally prefer this one because that's the more traditional way of doing it in R. I use this way because it's one less character, but also because I do a lot of programming in other programming languages, and in most programming languages like Python, this is how it's done. It's completely a matter of convention. You can choose to use this one, you can choose to use this one. I don't really care. Use whichever you want. It's probably a good idea to stay consistent in your choice. But again, on the internet, you'll probably see a lot of people use this notation, which is totally equivalent to this notation, so don't worry about the difference either. All right, now, good luck, have fun with this practice session, and see you soon.